Hi, and welcome back to my YouTube page. I'm Sarah Fuentes, a math teacher in New York and also an instructional specialist and coach. And today's topic and lesson will be on dividing fractions. So my aim would be, what does it mean to divide a fraction, and why don't we flip that second fraction around and multiply? And this is a huge topic in sixth grade mathematics. So first, let's just think about what it actually means to divide, and we'll think about it with whole numbers first, because that makes it easier when we're thinking of a concept. And when we divide, we're just trying to evenly share. We're trying to share something with other people in repeated groups to make sure everyone has the same. And I like to think about my total a lot. Like, what is my total? What is the whole thing I have? And how am I trying to share it? In what kind of way? So over here, I'm pretending these are candies. And what if I have 18 candies and I want to share with 4 friends? So that's what I'm thinking of, 18 divided by 4. How many can I give each friend? So one thing I know, 18 is not a really easy number to divide by 4, but I know that if I had 16, I can give everybody 4 pieces. So like I can give one friend 4, I can give another friend 4, I can give another friend 4, and I can give this friend 4. So I can have 4 nice big groups of 4, but notice I have some leftovers. So I have 2 leftover out of 4. So that's kind of what I think about when dividing. As you get older, you could even think, well, why can't we break the candy pieces apart? So as you get a little older, you start to, maybe around 5th and 6th grade, you start thinking this way and say, well, instead of having a remainder, what if I gave each little person a half a candy? A little half piece, and this person gets a half, and this person gets a half. So everyone gets 4.5 pieces each, or 4.5 pieces. That's another way of thinking about this type of problem. We're just evenly sharing. So when I have something I can break apart, context makes sense. But when I have fractions, it makes it even harder, because now I don't have whole pieces. I have pieces of a certain size I'm thinking about. So this is a very common 6th grade problem. It's looking at a model with bars, and I love bar models, as you know. And here, this is my whole group, and I'm looking at it and noticing that I have, looking at my numbers here, up top, I have 1 whole piece, 2 whole pieces, but I don't have enough for 3 pieces. So I have 2 pieces and another piece over here. So 2 pieces, and over here I have 1/3. So I'm going to put that in. My whole thing, my total, is 2 and 1/3. And here I'm just trying to see what the model represents. And when I look at the bottom part, I'm breaking it up into these 2/3 pieces. So how many of these 2/3 fit in here? And you can take a look and see I can fit 3 whole ones. And then here I have half of a piece. So notice I'm taking it and I'm breaking it up into 2/3. I'm trying to figure out how many 2/3. And just like I was showing in the picture, I have 1 whole set of 2/3, 2 whole sets of 2/3, 3 whole sets of 2/3, and a half. So I can even see I have 3.5 pieces here. And this is, of course, just looking at a model, so you can just see that I have a fractional piece, so I don't have a whole. And what makes this hard is I'm breaking it up into smaller pieces. So somehow my model has to show that when I'm dividing. And that's what makes dividing with fractions kind of hard to conceptualize, because I'm breaking things into pieces of pieces. So what I would recommend is using grid paper and looking at arrays. So let's see what we're talking about here. And I'm going to look at this first problem up top. And what is the value of 5/6 divided by 3/4? Now, let's be honest for a second. This is what I know most people are going to do. Most people are going to just say, change the division to multiplication, and you're going to flip the second one around. I see it's all around. Keep, change, flip. Some of my kids are always confused with KFC, like the Kentucky Fried Chicken. Keep, change, flip. That's what they know they're supposed to do, and they're somehow going to get 35/18. But what does this even mean? So what I'm going to do is I'm going to look at it as a model again. And we're going to try thinking First off, I drew out a big square, and on the top part I have, let's see, 1, 2, 3, 4, 5, 6. So I drew out 6 pieces because I want to try and represent 5, 6. So if I have 6 pieces here, what if I only want to show 1, 2, 3, 4, 5 of the rows? I'm thinking I'm going down 1 row, 2 row, 3 row, 4 row, 5 rows. So I'm going to kind of separate that with the red now. Yep, thank you. So just imagine that I'm only thinking about this part here. 5, 6. This part doesn't matter over here. That 1, 6 doesn't matter. And the other thing you'll notice is down here, I counted out 1, 2, 3, 4, 5, 6, 7. Why? Because I have 7 pieces here. So you can see my reasoning. I have 6 rows here because I have 6 pieces here. And I have 7 rows here because I have 7 rows there. And so just thinking about this whole thing here, I know I'm going to somehow divide this into 3 7s. Okay. So let's just think about what we got here. Just thinking about my 5, 6. I know in this piece here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35 pieces. I'm going to say that's important for this to know. I kind of just noticed something. My 35 pieces are right over here, my 35 pieces. I wonder if that's going to mean anything. And I know if I were to break something up into 3 7s. 3 7s. Oops, this should be a division sign. Excuse me for that mistake. Not a multiplication. A division sign. So if I want to break this up into 3 7s, and I know I have 7s here. 1, 2, 3, 4, 5, 6, 7. I'm going to imagine I want this part over here. Like, how big is that part? So let's just think about this for a little bit, just so we can see the line. This section here represents 3 7s of my whole thing, of my whole box, of my whole array. And that means I would need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 pieces. So 3 7s is in this place 18 pieces. Okay. And of course this matters because I'm looking at how many pieces I have here. And I'm noticing something else. I'm noticing 18 here and 18 happening over here. Interesting. All right. So let's go and start thinking again of what I would have to do. So I need 18 pieces to make up 3 7s. Okay. That's what I'm thinking about right now. So I'm going to just count out how many pieces fit in there. 3, 4, 5. I want to say 6, but I can't because remember this piece over here doesn't matter. I cut it out. So let's take that out. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this is one whole piece. One whole 3 7s. It's a whole part that I get to take away. And now I can do another one. I'm going to share again. 18 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh, 17. I don't have enough for a second piece. I only have 17. So wait a minute. I had 35 pieces. I know I need 18 to make a whole, to share one of them. So I can share one whole piece. I have 18. And I only have 17 out of 18 left. So now let's look back at our other KFC for a minute and notice what happens here. So the first thing that's happening, 5 times 7, is really the top part is just telling me how many pieces I really have. That's when we multiply by reciprocal. I'm just figuring out how many pieces. Why 5 and not 6? Why am I not doing 6 times 7? Remember, because I only want this part of it. So I only want 5 6. So I'm multiplying 5 times the 7. That's where this comes in. It's telling me my pieces by the whole size on the other part. And I know I have 35 pieces. And the second part is telling me of these parts here, I want to know how many pieces make it up. So when I have this whole part here, I'm trying to figure out how many are in this section. I know I have 3 parts out of 6. That's where I'm getting my 18. That's over here. So this is telling me the size I'm sharing. And this is telling me my total pieces. That is why we multiply by a reciprocal, because it's really a way of making arrays and cutting up pieces that are not whole numbers into parts that we can see. Now, to be fair, we don't always need to know this to be able to do the algorithm. But that's why we do keep change flip. It's because we're really figuring out how many pieces we have from a number that's not complete. And so I multiply by reciprocal, and then how many pieces I need to share. And so once I do that, I know that out of 35 pieces I have, I need to share them into 18 pieces. And of course, for this problem, I don't have to simplify. I can just see it right here. But I could have gone further and just simplified that out and figured out that if I have 35 pieces out of 18, this is the same thing as 35 divided by 18, which makes one whole group and 17 out of 18. That's what's happening when we're dividing with fractions. So I hope this actually helps a lot of viewers who ever wondered, or even teachers, to be fair. I know tons of adults who don't know why we multiply by reciprocal. And again, it has to do with this array model and figuring out number of pieces. Okay? So I hope this makes sense, and I hope this really, really helps out with a lot of individuals who are struggling with these types of problems. So as always, I hope you found this video informative. Leave questions and comments below. I love answering and engaging. And if you have new topics that you would like to share, by all means, you can just email me at sarah@mathminilessons, or you can follow my Facebook page, Math Mini Lessons as well. I love hearing questions from kids and from families and teachers. And as always, I will see you next week. Have a great day.